Hello everyone. So in the last videos, we have already covered some parts of the Svelte. We'll continue the journey and we'll explore further. We had already covered introductions, reactivity in one video, props, logic, events, and bindings in another video. And then we had covered classes, attachments, and transition in the last video. So that covers the basic Svelte. We'll move on to advanced Svelte for now. So let's get to, or if we want to cover basically this, we can cover this. In Svelte, we basically create HTML, CSS, and JavaScript, all the three in single file. And the activity is achieved with $state, and then we can have effects as well, and we can have universal effect, we can have deep reactivity. So we already discussed how to use derived states, and then we discussed how to pass props. It's similar to React. And then we discussed logic, if else, and key, and iterating over keys and making sure that IDs are assigned similar to React. Similarly, we discussed events, inline handlers, capturing and bubbling, and compound event and spreading event. Similarly, we discussed bindings, how Svelte provides bindings for most of the standard inputs. And then we discussed about classes, how to apply class, and there is a style directive which we can use, and then there is a component styles that we can provide. So and then we discussed about attachment and we discussed how you can use attachments, and then we discussed how Svelte already provides transitions and functionalities related to transition. Now let's move to the advanced Svelte. We'll explore what is there in advanced Svelte. So first is advanced reactivity. In previous exercises we learned that Svelte is deeply reactive. Yes, if you for example change a property of an object or push to an array, it will cause the UI to update. This works by creating a proxy that intercepts read and write, so it does not directly mutate the actual object itself, but rather creates a proxy, and then it reads and writes with that proxy. Similar to signals, if you are familiar with signals, which is a concept from SolidJS, which was recently added to Angular as well. Occasionally, that's not what you want if you are not changing individual properties, or if it is important to maintain differential equality, then you can use a raw state instead. This is interesting. If you are not changing individual property, then it's important to maintain differential equality. So if you want functionality similar to other frameworks like React and Angular, then you can use raw state as well, where deep reactivity is not there. In this I guess so. In this example, we have a chart of Svelte steadily increasing stock price. So this is the chart of Svelte stock price. We want to chart to update when a new data comes in, which we could achieve by turning data into state. So let's say we have this data which is coming from this poll, and let's say we convert it into a state. We say $state, and that's a state. This is interesting, but there's no need to make it deeply reactive when it will be discarded a few milliseconds later. Instead, use this state dot raw. Raw. So this mutating raw state will have no direct effect. In general, mutating non-reactive state is strongly discouraged. Mutating raw state will have no direct effect. So if you are mutating this, there would be no effect because they are working on a raw state. In general, mutating non-reactive state is strongly discouraged. Yes, because it won't update directly. So this is the data, which is a raw data. Any change in the pole should be referential change, and from here we are getting one width and height, and then we are deriving math of minimum of data, maximum of data, and then derived scale like this, take derived, and then there is functionality to it. Let's ignore that for now. It's not just variable that can be made reactive in Svelte. We can also make properties of a classes reactive. So let's make the width and height properties or box class reactive. So in this class, box width and height is there. So we can make this reactive as well. Now when we interact with the range input or click the begin button, this react. So if we do this, right? If we do this or if we do this, right? We can also use derived so that the box dot area updates reactively. So we can update the area which is here. So currently if I change this, it updates, and if I change this updates. And if we change box area, let's say, which says state, this uh, this should not be state, this should be derived state, which is basically this dot width into this dot height. So this is a width and this is a height, and then this should be like this. So if we try this now, okay, so now this values is changing as well, area on. In addition, state and derived, you can use state.raw and derived.by to define reactive field. So we can say state.raw and state.raw. Let's say we do this, then still it would work. And derived.by. And how do they differ? Not sure. This is derived.by to define reactive field. Okay, there is no definition provided to it, so we will ignore for now. Classes are particularly useful when you need to validate data. So in the case of a box class, it shouldn't be possible to keep in beginning past the maximum allowed by the slider, but that's exactly what happens. We can fix this by replacing width and height with getters and setter, otherwise known as accessors. First convert them to a private property. So what happens is this 200 and this is this. So if we say let's say hash property, hash this, so these are the private properties, and we say this dot hash, and we say this dot hash, and now there is a constructor which says this dot hash and this dot hash. So there is this hash which is being applied there, then create some getters and setters. So in box here we would have get width. So let's say width, which should be written this dot hash width. Similarly, get height, get height, and this should be set width. We should have a value, and this should be like this, and this should be height, and this height goes here. So this way, finally add the validation to the setter. So if we have a setter, so if we are doing this and then we are doing this, so when we are setting this in this width, we can simply say math dot max of 0 comma math dot min of max size comma value. Take the minimum of maximum size and value. whichever is the minimum, and then take maximum of 0 or this, so it should result into this value. Similarly for height, we should have similar equations like this, where we say math dot max 0, math dot mean, max size and value. So we said this, it's now impossible to increase the box size past safe limit, whether through the bind dot value on the range input or the imagine method. So we do this. Earlier without this, I guess it was possible with imagine. So okay, next is reactive reactive built-ins. So Svelte ships with several reactive classes that you can use in place of a JavaScript built-in object, namely map, set, date, URL, and URL search params. In this exercise, we could declare date using state, reactive state, and new date, and reassign it inside the state interval. But a nice alternative to use a SvelteDate from this. So how does this differ? Not sure. Let's see. So we can simply say import, we say SvelteDate from Svelte Reactivity. So we define SvelteDate and then there is a SvelteDate. So use date. Steps is several reactive classes that you can use to in place of JavaScript built-in object, namely map, set, date, URL. Okay, so they are providing by default. Now this is the interesting piece, using the store. Prior to the introduction of runes in Svelte 5, stores were the idiomatic way to handle reactive state outside component. Okay, that's no longer the case, but you will still encounter store when using Svelte, including in SvelteKit. For now, it's worth knowing how to use them. We won't cover how to create your own custom store. For that, consult the documentation. Let's revisit the example from the universal reactivity exercise, but this time implement the shared state using a store. Okay, in a share.js, we are currently exporting a count, which is an turn it into a writable store. So let's say export const count, and that should be writable, and writable should be imported from so this is a writable store which has a count 0. To reference the value of the store, we prefix it with the dollar symbol in counter dot counter dot swelt, this is the dollar, and then we say dollar. So with this we are getting count from this, which is a writable store. So it no longer says this. Finally, at the event handler, because this is a writable store, we can update the value programmatically using its set or update method. So in the counter, we can say on click count, and it should say count dot update, and it should say n plus 1. Right, since we are in a component, we can continue using the dollar prefix. We are in a component, so we can continue using. So uh, on click we can simply say Let's remove this and we simply say dollar count. But since we are in a component, we can continue using the dollar prefix. So on click is there, which is a function, and we say counter. Okay, counter should be plus equals to 1. We increase this like this, or another way was to update it or set it like this. This is interesting. So this was advanced reactivity, I guess. So we'll cover that was all in this video. We'll cover reusing content in another video. Thank you.